you could save $23,000 in your annual energy spend, pay for it in about 2 weeks, and install it in about 10 minutes, would you do it? Did you also know that worn equipment and poorly tensioned belt drives can cost you thousands of dollars a year? Hi, I'm Sean Carnes with Browning. We've been spending some time talking to building managers and chief engineers about their energy spend as it relates to fans and blowers. Don Sullivan's here with me, and he's going to give you some perspective on how much you can save in your building.
We're going to explore the different types of applications in these types of buildings and talk to you about potential energy savings.
We can categorize belt-driven fan applications into 4 categories. The first is cooling towers. Cooling towers are widely used in every metropolitan city. They're often found in hospitals, universities, and office buildings. Package units are used as part of the HVAC system. They are self-contained with all the components used to pull air from the occupied space, filter, cool, and then blow it back into the area. Up and down blast exhaust fans are commonly found in commercial cooking applications. Blowers are the most frequently encountered fan systems, and they're used to push or pull air through the HVAC system. The supply blowers are used to pull the air from the occupied space to the system, where the air can be filtered and a thermal exchange can take place. Once complete, the air is then sent back to the building for occupant comfort. The U.S. Department of Energy publishes that notched V-belts, often called cogged V-belts, are more energy efficient than standard wrapped V-belts. They also publish that they run cooler, they last longer. Independent tests have shown an efficiency gain of about 3%. Energy responsibility with belt-driven fan applications can be managed in 4 easy steps. The first is to upgrade from a wrap to a notch-style V-belt and improve your efficiency about 3%. They utilize the same pulleys or sheaves that the standard wrap V-belts do, and it's a drop-in replacement. The second step is to inspect sheaves for wear. Worn sheaves allow belt slip. Wear greater than 1/32 of an inch can decrease efficiency 5% or more. Step 3 is properly tensioning belts. The U.S. Department of Energy states that efficiency can deteriorate by as much as 5% over time if slippage occurs because the belt is not periodically retensioned. The fourth step is the installation of a self-adjusting motor base. Our Browning Tenzo set base provides constant spring tension, and they automatically compensate for belt wear, which reduces the frequency of belt adjustments.
Well, that's it. Browning understands how important your energy savings is to you. We hope that you've seen the potential for dramatic savings using the 4 easy steps that Don outlined. Contact your local authorized Browning supplier today. We're looking forward to seeing you and talking with you about your energy savings.